This is proposition 6.1. I will start from proposition 6.1 and also I will include some of the questions certainly based on the same. Just suppose, for example, by giving the example, we can understand the thing easily. Just suppose you are having n equals to 8 gifts. There are 8 gifts you are having, and you have 3 brothers. How many brothers you have? 3 brothers. Say the brother A is there, brother B is there, brother C is there. You can just name them. The question here is, how can you divide your 8 gifts? How can you divide your 8 gifts into 3 of your brothers such that every brother should get at least one gift? Every brother should get at least one gift. In this case, what you can assume that you give A to n1 number of gifts, or you can assume x1 like the notation is there. To B, you give x2 number of gifts, and to C, you give x3 number of gifts there. The condition here is everyone must have got at least one gift. Everyone should have got at least one gift. So x1 bigger than 0, x2 bigger than 0, x3 bigger than 0. So how can we formulate this problem? This problem is actually then, it is equivalent to solving for non-negative, basically I should say positive solution for this problem is x1 plus x2 plus x3 equals to 8. This is the equation you have to solve such that each xi should be positive. So whenever this is the case there, how many integer solutions are there? Positive integer solutions are there. The answer is going to be your n minus 1 r minus 1 total possible ways. Total ways. The question is, how can we say it is n minus 1, r minus 1? I will give you the example and then after we'll elaborate. We will try to just generalize the case there. So just suppose there are 8 gifts, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 gifts. Okay, you want to divide them into 3. This is what we're gonna do. We can divide them. We can divide them. See, there are gaps 1, 2, 3, 4, 5, 6, 7. There are 7 gaps. If I draw two vertical line anywhere, then the whole 8 gifts are divided into 3 parts. Part 1, part 2, and part 3. By using 2 lines, you can divide them into 3 parts. Part 1 may go to A, part 2 may go to B, part 3 may go to C there. Now, how many such lines are possible? See, I used basically how many? N minus 1, that is equals to 8 minus 1 equal to 7 places. There are 7 in between places. Were 7 places in between these 8 gifts, and I used how many vertical lines? I used 2 vertical lines to divide them into 3 parts. So how I get 2? It is basically total 3 was required. Total 3 was required. 3 minus 1 equals to 2 there. So technically, your n minus 1, r minus 1 stands for n minus 1 is 7, n minus 1 is 7, r minus 1 is 2 there. So therefore, the answer is 7c2. And 7c2 you can further simplify if you wish. It is going to be 7 into 6 divided by 2 factorial. 2 factorial is 2. So it is 7 into 3, that is simply 21. Let us now go to the proposition number 2 there. In proposition number 2, the situation here is there are n different objects. You need to divide these n different objects into R groups, x1, x2 up to xr, such that such that anyone can receive any number of integers up to n, any number of positive integers. In this, in proportion 6.2, in proportion 6.20, what we have to do, n objects are to be divided into R groups, x1, x2, xr, and we are looking for the non-negative integer valued solution. So if this is the situation, like we have discussed in the 6.1, assume that xi plus 1. Assume this to be yi. So yi must be bigger than equal to 1 because xi is bigger than equal to 0. If you add 1 on both sides and call xi plus 1 to be yi, so certainly yi is 1. That means to say that simply, let me tell you once more, x1 can take any value bigger than equal to 0. What you do, you just add 1 both side. If you add 1 both side, I'm assuming the left hand side to be y1. So y1 is bigger than equal to 1. Okay. So similarly, my x2 is bigger than equal to 0. Let me just add 1 there. Let me just add 1 there on both sides. So now I'm going to have y2 is bigger than equal to 1. If I do so, my yn is going to be bigger than equal to 1. Not yn, it is yr. Now tell me, if I add y1 plus y2 plus up to yr, is it the same thing if I write x1 plus 1, x2 plus 1, and up to xr plus 1? Is it the same thing? If you add them, it is x1 plus x2 plus up to xr. And then after there are r terms like this, one is appearing r times, so it is going to be equal to r. From the given problem, you have the value of x1 plus x2 up to xr equal to n. So let me write down, it is going to be n plus r there, n plus r there, and y1 plus y2 plus up to yr is equal to n plus r. So the given problem is now converted into another problem where any yi will take at least one solution. That means positive solution, positive integer solution we need. But we have formula 6 point from proposition 6.1. We have total such possibilities, total such possibility, that is number of positive solution is going to be how much? It is going to be n minus 1 cr minus 1. Check once more. The role of n is played by n plus r this time. You can just correlate the same situation from 6.1. This is going to be how much? If you write n plus r minus 1, r minus 1. So you will see a similar type of question later on also. So for example, if I ask you, there are n equals to 8 gifts, and you need to divide these 8 gifts into 3 brothers A, B, 3 brothers are there, and anyone can receive any number of gifts, and anyone can receive any number of gifts. So basically, x1 stands for number of gifts to A, number of gifts to A, and this can be anything bigger than 0. Similarly, you can define an x2 and x3 there. The question here is, how many integer solutions are available to the problem x1 plus x2 plus x3 equal to 8 and my xi bigger than equal to 0. So using the formula, you can answer total such cases are going to be n plus r minus 1, r minus 1. What is n there? N has the value 8. 8 gifts has to be distributed. What is r there? 3. 3 groups are there. 3 brothers are there. Minus 1, 3 minus 1. 8 plus 3 minus 1 is what? It is going to be 11 minus 1, that is 10. C2 there. You can simplify the answer. You can simplify it to get the answer. It is going to be 5 of 9 are 45. So there are 45 such possibilities. Let us just try to apply the same to some of the questions. The question here is, how many distinct non-negative integers? Non-negative integer, that means the solution may be bigger than equal to 0. Non-negative integers are there. Solution for x1 plus x2 equals to 3 there. So whenever you are having x1 plus x2 equals to 3, n is going to be 3 for you. How many solutions are required? 2 solutions are required. So total possibilities, total possibilities are going to be n plus R minus 1, C R minus 1. Substitute the value 3 plus 2 minus 1, then 2 minus 1. Simplify. It is 5 minus 1, 4. It is 2 minus 1, 1. 4C1 is going to be 4 there. And if you wish to count the possibilities, see, you can give 0, 3, x1 is 0 and x2 is 3, and vice versa. You can take 1 and 2 there, you can take 2 and 1 there, and you can take 3 and 0 there. These are the possibilities we can have. So we have divided three things into two, and anyone can get 0, anyone can get maximum 3 there, and in between 1, 2, 2, 1, everyone. An investor has $20,000 to invest among four possible investments. Each investor must be in units of $1,000. If total 20,000 is to be invested, how many different investment strategies are possible? So just suppose there are 20 items like the 1,000, just 20 items. You have to divide them into four investment. Just suppose X1 is the amount, number of dollars in thousand given in first investment. X2 is given to the second investment. X3 is given to the third statement investment. X4 is given to the fourth investment. And the condition is you can actually invest only $20,000. So the total answer is going to be 20,000 there. So here, how many 1,000 you have? 20. 20 you have to divide into 4. Okay. And how many solutions are there? This is what we have to consider. Now, there is a possibility that in any of the investment, the number of dollars you invest can be 0 and can be 20 depending upon the situation. So x2 may be bigger than equal to 0, x3 may be bigger than equal to 0, x4 may be bigger than equal to 0. So we are looking for non-negative solution. We are looking for non-negative solution. And whenever we look for non-negative solution, then proposition 6.2, which says that number of solutions are n plus r minus 1, c r minus 1, this proposition is going to be used. So the answer of the question is number of investment strategies is going to be n plus r, 20 plus r minus 1, c r minus 1. So you simplify this. This is going to be how much? 20 plus 4 is 24 minus 23 there. C3. You can calculate this question and you can easily find the answer. Okay, you can easily find the answer. Now, there is a B part of the question. B part says that what if not all the money invested? If all the money, if all the money is not invested, then what may be the possibility? So there are four investments like before: x1, x2, x3, x4, and there may be a possibility that some amount may be unused. Unused amount. Check. You have to invest up to 20,000 in four investment, and obviously you may not invest all the amount. That means there must be some unused amount. So let me assume that their unused amount be x5. So now the question becomes the sum of all the investment x1, x2, x3, x4 and addition of unused amount should be 20 there. And the condition here is anyone can be 0 or positive. So again, we will use proposition 6.2. In this case, the total possibilities are total possible strategies are going to be how much? It is n plus r minus 1, and then after r minus 1 it is 5 minus 1. You get the answer. Simplify, it is should be 24c4. You can simplify then and you can get the answer. I hope no issues are there. Okay, next, after this there is a multinomial theorem, and we have discussed multinomial theorem before also. And what it says, it is basically a generalization of the binomial theorem. We know how to expand x plus y power n. There are two terms, one is x, other is y there. So if there are more than two terms, how to expand them? We have seen this type of questions before also. Okay, we have seen this type of question before also. So I'm not going to repeat myself, but I may ask you the question. Just suppose x1 plus x2 plus x3 power 6 is there. The question is, what is the coefficient of the multinomial 6, 2, 3, 1? Or sorry, the coefficient of x1 power 2, x2 power 3, and x3 power 1. What may be the coefficient of this term? If you expand using the multinomial, what may be the coefficient of this? So always remember, whenever I ask you about the coefficient, you have to make use of the multinomial, which says that this is your n. Your n is divided into three parts. One is n1, it is the exponent of x1. Another one is n2, exponent of x2. And then after n3, exponent of n3. And the condition here is n1 plus n2 plus n3 should be equal to n there. So now if I have to find the coefficient of this term, check the exponent. The exponents are 2, 3, and 1. These are the three exponents you have. If you add them, what you get? You get 6. So the condition is satisfied. That means we can have a coefficient. Just write the coefficient. It is going to be 6. Then after 2, 3, 1, separated by comma, it is equal to 6 factorial divided by 2 factorial, 3 factorial, 1 factorial. Okay, so this is going to be the coefficient of x1 square, x2 cube, x3 power 1. On a similar basis, if I ask you what is the coefficient of x1 power 0, x2 power 4, and x3 power 1. If this is the question, the answer is there is no coefficient. Why no coefficient? Because if you add the exponent 0, 4, 1, it is 5, which is not equal to 6. And we are having n equals 6 there. So in this case, no coefficient will be there in the expansion of x1 plus x2 plus x3 whole power 6. So we have seen we have not expanded this term. Even then, we are looking for what is going to be the coefficient of x1 square, x2 cube, x3 1. We are able to find the answer using the multinomial. Okay, and yes, this is not going to be a term in the expansion of x1 plus x2 plus x3 whole power 6. Reason being, the sum of the exponent is not equal to 6 here. Okay, I hope this question should be understood by now. Now there is one more term need to be discussed here before ending this portion. Yes, this is going to be something very important. How many terms are there in a multinomial? Let me just write down how to write this multinomial. If I need to find out the expansion of x1 plus x2 plus x3 plus dot 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 up to xn whole power n, then it is going to be equal to the summation, then multinomial n, n1, n2, then after n r there, this is r there. Then after x1 power n1 exponent, x2 exponent n2 multiplied up to xr exponent nr. So this is going to be the sum of this. What is this sum here? What it represent? The sum is over all solutions of n1 plus n2 plus up to nr equals to n. Check maybe on we discussed the similar type of question in the previous example. There was an example x1 plus x2 plus x3 power 6 there. I asked you, is this a term? Is this a term? That means some coefficient of this term should be in the expansion. The answer is yes. And how? Because the sum of the exponent is n. Here the sum of the exponent is not n. So this is not going to be term here. So basically, there will be some exponent of x1, x2, xr. It will be a term if the sum of n1, n2, nr, the exponent is going to be n. And check each ni can be either 0 or bigger than, can be 0 or positive. This is the condition we have. So basically, if I ask you how many total terms are there, so total terms, it is the same thing asking you number of non-negative solutions. Non-negative solutions of the equation n1, n2, nr. And using proportion 6.3, we know the answer. It is n plus r minus 1, c r minus 1. So if I ask you how many total terms are there, you can give the answer. So consider the previous question, x1 plus x2 plus x3 power r. And I ask you without expansion, how many terms are there? How many terms are there? Without expansion, you will tell me it is going to be r, this was n, sorry, and n has the value 6 there. It is 6 plus, there are three divisions you have to do, x1, x2, x3, r is 3 there. Minus 1, it is going to be 3 minus 1. So it is going to be 8c2 there if there is no calculation mistake. And 8c2 is going to be 8 into 7 divided by 2 factorial. You know how to just expand NCR. So this is going to be 4 into 7. You divide 8 by 2 there. That is 20. So there will be total 28 terms in the expansion of x1 plus x2 plus x3 whole power 6 there. So I hope this concept should be understood and you should be able to know how to find the coefficient in any of the term using the multinomial. If the some terms are given to you, is it going to be a term in the expansion? If you can find out if the exponents are given to you. We can also tell without calculation how many total terms are there. So I hope these three questions should be understood by now. Is there any doubt? Is there any doubt? I hope no issues are there. Now let us just talk about some more questions based on the permutation combination given in the practice sessions. The question here is, first question, in how many ways, three boys and three girls sit in a row? So basically for the part A there are three boys, may have this three boys, let me consider B1, B2, B3, and there are three girls, 1, 2, 3. It is going to be G1, G2, G3. They can sit together. So basically there are total 6 people. There are total 6 people. And if there are total 6 people, how can we arrange them? So total arrangement is going to be, out of 6 you have to choose 6. Okay, you can use the permutation. Basically out of 6 we have to use 6, we have to use 6 all, and permutation order is important. So this term is technically going to be 6 factorial, and 6 factorial is going to be 6 into 5 into 4 into 3 into 2 into 1 factor. You can simplify the answers. I hope it is going to be 720. Another way of dealing the same question is, you have 6 position, 1, 2, 3, 4, 5, 6. Now, how many possibilities at the first position? There are 6 possibilities. Okay, because there are 6 people. Now, if you fix 1 at the first, how many possibility for the second position? The answer is 5. If you fix a person at the second position, how many possibilities you have for the third position? There are 4 possibilities. Similarly, there are 3 possibilities left for the fourth case, 2 possibility left for the fifth case, and 1 possibility left for the last case. So how many total arrangements are there? You do the multiplication because you need to give the answer together. And it is going to be 6 factorial, and we have already seen what is the, we have already calculate it, what is going to be the answer here. Okay, so I hope there should not be any issue and this must be understood. Is there any doubt? Is there any doubt? I hope no issues are there. Now we can go to the next. The next question is the part B there. Next question is part B. Just look at the part B. In how many ways three boys, I should use highlighter, and three girls sit in a row if boys and girls are to sit together? The question here is the boys will sit together and the girls will sit together. So see, there may be a possibility, there may be a possibility that first these are the boys, B1, B2, B3 sit together, and these are the girls, G1, G2, G3. This may be the possibility. The other possibility may be the girls will sit at the first place. Let me G1, G2, G3. You have to, the question is sitting arrangement in a row. And then after you, there is a arrangement for the boys there. Your B1, B2, B3. These are the only two possibilities, nothing else. So now how can we deal with it? How these three boys can sit together? The answer is 3 factorial way, because there is a permutation. Okay, the total ways of sitting these three boys is going to be 3 factorial. How many ways these three girls can sit together? 3 factorial, because these 6 has to sit together, so we have to multiply them. So we are getting total number of cases like 3 factorial into 3 factorial. Similarly, if girls are going to sit together first, total ways are going to be 3 factorial. And then after boys will follow them, their permutation is 3 factorial. All 6 has to sit together. So this is going to be the total possibilities. So either first option is available or the second option is available. Therefore, total arrangement are total arrangements where boys will sit together and girls will sit together will be the sum of these two. 3 factorial plus 3 factorial 3 factorial, and it is going to be 2 into 3 factorial into 3 factorial. You can simplify, you can calculate them. 3 factorial is 6, 3 factorial is 6. You can easily calculate the answer. Maybe the answer is going to be 72. Just have a look. If you have any doubt, just let me know. Okay. Now, if no issues are there, let us just try the C and the D part. Let me take the screenshot. Otherwise, I have to go back every time. Now, check the C part there. In how many ways, if one of the boys must, if the boys must sit together? In the C part, the situation is there is a box. Assume that this is a box, and in this box, 3 boys are there: B1, B2, B3. And girls, you have to just place this box anywhere in between girls, maybe at the end and anywhere. So whenever you have to, whenever there is a situation when you have to take the decision of sitting together, you consider them as single unit, because you have these boys will sit together. You consider them as a single unit. So how many total people are there? How many total persons are there? Total persons are going to be, there are 3 girls plus 1 unit. So there are 4 places required. So what is the permutation there? What is the total arrangement there? The answer is going to be 4 places, 3 girls, 1 unit, this box. Total places are going to be 4 factorial using the formula 4p4. 4 factorial. And but the question here is, these boys can arrange their position also. So how many ways these boys can arrange their position? The answer is 3 factorial. So basically, total, this is the permutation of 4 people. Now total arrangements, we need to find total arrangements. Total arrangements are going to be how much? It is going to be 4 factorial. Eh, 4 factorial is the number of ways these 4 units, 3 girls, 1 unit can be arranged. Then after, these 3 boys can arrange their self. So the answer is going to be multiplied by 3 factorial and whatever the answer. Clear? This is the C part for you. And last, we have the D part there. D part is how many ways of no two people of the same sex are allowed. No two people of the same sex are allowed. That means if a boy is there, then after next is a girl, boy, girl, boy, girl. This is one possibility. Other possibility is going to be girl, boy, girl, boy, girl, boy. These are the two possibilities. Either first one will be there or the second one will be there. If first one is there, that means the position of boy is fixed and the position of girl is fixed. So how many total arrangements are there? For the first case, there are 3 positions and 3 boys have to be sit there. So how many arrangements are there? 3 factorial. For the girls, you have 3 places. 3 girls will sit there with the permutation. Total arrangement 3 factorial. This is the first case. Similarly, in the second case, first girls will sit. So how many places are there? How many arrangements are there? 3 factorial. What about boys? It is going to be 3 factorial again. What is the total score? It is going to be 2 into 3 factorial multiplied by 3 factorial. You will calculate the answer, and I hope it is going to be an easy task for you. Okay, so this is how we have discussed question number 1 given in the practice questions. If there is any doubt, you just let me know. Okay, no doubts are there. So let us just try to have similar type of questions. In how many ways 8 people be seated in a row? 8 people be seated in a row. There are n equals to 8 people. There are n equals 8 people. There is no restriction. If there is no restriction, so the total arrangement is going to be out of 8. We need to take 8 in arrangement. It is going to be 8 factorial. 8 factorial, you know the answer. Okay, it is not a big task for you. Now for the B part. B part, it says that two person A, B must sit next to each other. So there are two person A, B. They should sit next to each other. So if you just consider AB as a single unit, like we consider the last case, I'm considering this as a single unit. So how many total people are there? So total people for arrangement are going to be, there were 8 total peoples. Now I have deleted, I have subtracted 2 of them because I'm considering them as a single unit. So if you're considering them as a single unit, this is the place I will place them. -2 stands for these, the position of AB is going to be deleted. And I'm replacing them with +1. So check, total people were 8 there. Now 2 have to sit together. I consider them as single unit. So I subtracted their numbering here, -2, but added the position, single unit. So it is going to be how much? 8 minus 2 is 6, that is 7 there. So what is the total arrangement of these 7 people? Total arrangement of these 7 people is going to be 7 factorial. Okay, this is 7 factorial. Now there is a question, whatever you have in this single unit, they can have 2 types of permutation. Either AB is there or BA is there. They can interchange their positions. They can interchange their positions. So basically, total arrangement of 8 people is going to be 7 factorial. These are the these are for the 7 places. But yes, AB, which is single unit, may have 2 permutations here. I'm multiplying it by 2 factorial. So this is your answer. Last time I multiplied by 3 factorial. This time 2 factorial because I have only 2 person in the single unit. Okay. Now consider the C part there. There are four men and four women, and no two women can sit next to each other. This is a similar type of question like the last D part we have seen in the previous question. So if this is the case, four women, four men are there. So how can we sit them? How can we sit them? The answer is, if you start with the men there, then after woman, men, woman, man, woman, and man, woman. This is one such possibility. Another such possibility is going to be woman, man, woman, man, woman, man, and woman, man. These are the only two possibilities. And there are four men, four women. You can check the calculation. No two men, no two women can sit next to each other. So everyone is basically no two women and no two men are sitting next to each other. How many possibilities are there? Total arrangement for the first type is going to be 4 factorial multiplied by 4 factorial. Why? There were 4 places for men. They can rearrange their self. So how many ways they can rearrange? It is 4 factorial. Similarly, there are 4 women. So they can rearrange their position. How many ways they can rearrange? It is going to be 4 factorial. Similarly, we can talk about the total arrangement for the second case. Total arrangements are there. Is going to be first arrange for women, then after arrange for men. These are the only two possibilities. These are the only two possibilities. So total arrangements are going to be total arrangement satisfying the condition no two men or women can sit together. How many possibilities are there? Is going to be 2, because these are the two only possibilities. Multiply 4 factorial, 4 factorial, and you will get the answer. Is there any doubt? I hope no issues are there. Okay, I hope no issues are there. So this is the part, this is the C part for you. Let us go to the D part there. In the D part, there are 5 men and they must sit next to each other. In the D part, there are 5 men. So obviously there will be 3 women and they must sit together. So in this case, I will consider them as single unit. So how many total places are there? Sorry, how many total people are there? Total people for which I have to arrange the seats is 3 women. Sorry, there were 8 people. Okay, out of them 5 have to be kept in a single place. So you subtract their positions plus consider one place for them. Okay, so it is going to be how much? 8 minus 5 is 3 plus 1 4. Or alternatively, what you can say, there are 3 women plus 1 unit, one single unit. So there are 4 places required. There are 4 places required. So because 5 men are there, they can arrange their sitting arrangement. So total arrangements of 5 men together is going to be 5 factorial. Because we have 4 places, so how many total arrangements are there? Total arrangement of 3 women plus 1 unit is going to be 4 factorial. So you can arrange these 3 women and 1 unit like 4 factorial ways. Men can arrange themselves with 5 factorial ways. So total such arrangement. In this arrangement, first you arrange the position, and then after these 5 men will arrange themselves. So the answer is going to be 4 factorial into 5 factorial. Whatever the answer, you can find the answer. Okay, whatever the answer, you can find the answer. This is your D part. Let us Let me just take the screenshot for the E part, and then after we'll discuss E part. Let me just take this E part there. There are four married couples. See, in total, you are having eight people. Out of them, four married couples are there. Okay, four married couples are there. Each couple must sit together. So this is the place for first couple, second couple, third couple, fourth couple. Let me just give them the name A, B, C, D. These are the four couples you have. Okay, so these are the four couples you can have. So how many ways you can have the permutation? The answer is 4 factorial because there are four couples. You can arrange them in 4 factorial ways. But every pair, this is a pair basically. It is A1, A2. Okay, just suppose because it is a pair A1, A2. So there is another permutation possible A2, A1. You need to calculate all the arrangements. So at the first place, you have the two possibilities because the arrangements are A1, A2, A2, A1. Similarly, you have two possibilities for the second case. You can consider B1, B2 or B2, B1 like the sitting arrangement. Similarly, you have two possibilities for the third case and you have two possibilities for the last case. So the total answer is going to be 4 factorial into 2 to the power 4. Is there any doubt? I hope no doubts are there. Okay, I hope no doubts are there. I hope this should be understood. So after this, let us go to the next question. Just have a look at the next question. The question here is five separate awards, best scholarship. Check best scholarship. Let me just give me a second. Yes. Best scholarship, best leadership qualities, and so on. There are five types of award are there. You can give presented to students from a class of 30. There are 30 students available. How many different possibilities are there? So check there is a best scholarship award. So how many students are eligible for the same? There are 30 possibilities. 30 students are there for the scholarship award. How many people are there for the leadership award? Again, there are 30 because there is no restriction. Any student can take any number of prizes. For the third prizes, again there will be 30 possibilities. For the fourth prize, there is 30 possibility, and for the fifth prize, there are 30 possibilities because there is no restriction. Any student can take any number of them. Okay, any student can take any number of them. So for the first case, how many possibilities are there? Because you have to give the answer together. So in this case, the total possibility are going to be 30 raised to the power 5 there. Okay, 30 raised to the power 5 there. Now for the B part. Each student can receive at most one award. So it is the situation like five students are there having the position 1, 2, 3, 4, 5. Now, if a student is at position 1, he cannot be at position 2 also. Okay, certainly some other student will be there. So in this case, there are five awards 1, 2, 3, 4, 5 award there. There are 30 students available for the first prize, for example. Now, because a student can take only one award, at most one award, so for the second position, you will be having 29 students only because one student have taken this award. Now, because two students have taken the award, how many possibilities are there for the third case? 28. How many possibilities are there likewise for the fourth case? 27. And for the last case, it is 26 here. So total ways, the total possible outcomes are going to be, this is going to be 30 into 29 into 28 into 27 into 26, which otherwise you can write like 30p5 there. 30p5 stands for 30 objects are there. You have to talk about the permutation. Okay, you have to talk about the permutation of 5. You have to take 5 and you have to talk about the permutation. How many permutations are there? This is the answer. I hope no issues are there. It should be understood. Any doubt there? There is another question almost on the, no, it is not the on the same type. Sorry. The question number 4 is, consider a group of 20 people. If everyone shakes hand with everyone else, if everyone shakes hands with everyone else, how many shake hands takes place? This is something very good question, and you may have seen this question in some maybe one of the movie also. So similar type of question was there. The answer is any person. If 20 persons are there, you just choose any two-person from there. They can just shake the hands. Out of 20 people, you choose two people. Out of 20, just choose two people. So if you choose two people, so the number of possibility you will have is going to be the number of handshakes. So what is the answer there? It is going to be equal to number of handshakes. So what is the answer there? It is going to be 20, then after 19 divide by 2 there. You simplify them, 20, it is 10 into 19, and it is going to be 190 there. So there are total 190 handshakes are possible. Okay, out of 20, you need to just select any two there. I hope no issues are there. Now, next question, we have just a second, it is done. Yes. So we have also seen this type of question in class also. So please pay attention here for this question. From a group of 8 women, there are 8 women and 6 men. A committee consists of 3 men and 3 women is to be formed. Okay. The question here is, how many different committees are possible if 2 men refuses to serve together? Two particular men refuses to serve together. For the A part, the possibilities are the 2 men cannot work in a single team, but yes, single man can work. If you choose one of them, the committee will work. So how many possibilities are there? There are two ways. First way, and that out of 8 women, you select 3 women because there is no issue with the women. Okay, and for the men, out of 6 men, let me just remove these two particular men. So how many possibilities are there? 4. And out of 4, I need to select 3 there. So in this way, both are rejected. Both of 2 are rejected or are not the part of committee. In this case, in this case, the committee will work simply because there is no such condition. 2 of them are not there. But yes, in another way, there is no issue with the women. So let us take them together. So we need to take 3 men. We need to take 3 men. But if out of these two particular men who refuses to serve together, if I choose one of them only, so this is for men. Out of two who refused to work together, I'm choosing one. And out of the remaining 4 men, after the remaining 4 men, I choose 2 there. So in this case, I choose one of 2 men who refused to serve together. Who refused to serve together. These are the only cases we can have. So what is the total possible ways there? For the total possible ways, either first possibility that is there or second possibility is there. So total different committees is going to be double ES is going to be the sum of these two, 8C3, then after 4C3 and plus 8C3, 2C1 and 4C2. Is there any doubt? This is the first case you had. Similarly, you have the B case. In the B
Sir,
case,
can you repeat this question again?
sure. This B part, if you see, it is almost the same type. I have to repeat the same thing. Okay, just
Okay,
allow
sir.
me to repeat for the B part. Again, there are 8 women and 2 women refuses to serve together. A similar type of situation. So what may be the situation here? Out of 8 women, let me just eliminate these 2 women who refuses to serve together. Now, how many women I have? 6 women, and they don't have any issue with each other. They can work. Out of these 6, let me just take 3. And remaining 6 men, they don't have any issue. Let me just take 3 of them. So in this case, both of 2 women, which are both of 2 women who have an issue, are deleted. Are not the part. Any doubt? Are not the part of the committee. It is one situation. Another situation is there, like out of the 8 women, 2 women out of the 8 women, 2 women have some issues with each other. They cannot work in a single team, and 6 other women are there. They don't have any issue. Out of two, if I choose one of them, then the committee will work. And because I need 3 women, 1 woman already taken. How many women I need? 2 women. I choose 2 women from 6. Check. This is representing number of women. So there were 2 women, which 2 women cannot work together. So out of these two, let me just take one of them out. Okay. And out of the remaining 6 there, let me just take 2 women. So now the committee will work. Yes. Reason being, the committee will not work only in one situation where both women are there. Both particular 2 women are there, and we are taking only one. So no issues are there. What about men? There is no issue with the men. Out of 6, let me just take 3 there. Any doubt? So in this case, my total different committees are my total different committees are going to be the sum of both possibilities. It is 6C3 and 6C3 again, plus second one is 2C1, 6C2 and 6C3. Is there any doubt? Is there any doubt? I hope no issues are there. I hope no issues are there. Now there is C part also for the same question. C part also for the same question. In the C part, there were 8 women available. Check. There were 8 women available. There were 6 men available. And out of these, one man and one particular woman refuses to serve together. So how we can go? So there may be possibility we reject both. Reject both one man and one woman. This may be possibility. There may be another possibility. We reject this one man only. We do not take this one man in the committee. And there may be a third situation. We reject one woman. Okay. So these are the only 3 possibility. In all these 3 possibility, the committee will work. The condition the committee will not work is only one condition. These particular one man, one woman cannot work together. So just don't allow them to be together. So how many ways you can have? You need to have 3 women and 3 men. But out of 6 men, one man cannot be chosen because you are going to reject both one man and one woman. So how many men are available for to be the part of the committee? 5 men are available. Out of 5, I need to choose 3. And because I need to just remove one woman also. How many women were there? 8 women. So only 7 women are available to be the part of the committee, and you have to choose 3. This is the first way. In the second way, if only one woman is to be rejected, so one man is to be rejected. So there are only five men because one man is rejected. Let me just take three out of them. One man is rejected, and from seven women there, I need to choose how many? I need to choose how many? Uh, just a second. Maybe I need to choose basically.
Oh, sir.
Guess just a second. I need to choose two there. And why I need to choose two there? Because that particular woman is always the part. Particular one woman that has an issue with the man is going to be always the part because we have removed that man. Similarly, what may happen in the third case? Just try to tell me. One woman only rejected. So out of seven women, I need to choose three only. This is for the women case. Out of how many men? Six men are there. Or just a second. Yes, out of five men, I need to choose two men because one particular man will always be there. Let me tell you once more what I did here. This is going to be important. When I rejected both together, so out of six, you have five men, and out of eight, you have seven women. Clear? When you reject only one man, when you reject only one man, so basically, this one particular woman is always selected. It is always selected. It is always selected because if you delete them, we have already counted the case where both are not there. Okay, so one particular woman is also always selected. So one woman is selected always. How many women you need? Three. So out of the remaining seven, I need to choose only two women. And similarly, if you reject one woman only, and then in that case, the one man is going to be selected always. Because if he is not going to be selected, if he is not going to be selected, then we have the first case, which we have already counted. Okay, so for this particular case, out of six, five out of five men I am choosing two, and this one particular man is always selected. And always remember, your NCN is going to be one, so they are nothing but one. They are nothing but one. So now the total ways are going to be total possible committees are going to be the sum of these three cases. So let me write it is 5C3 for the first case, 7C3. Second is going to be 5C3 and 7C2 there. The third case is going to be how much? 7C3 and your 5C2. So this is how you can calculate them. Is there any doubt? I hope there may not be any issue. It should be an easy task for you. Okay, it should be an easy task for you. So after this, let us go to the next question there. Okay. In the next question, just read the question first. There are there are eight uh, teachers to be divided. There are eight teachers to be divided among four schools. Okay. So let us just discuss the question again. There are eight new teachers are there to be divided among four schools. How many such divisions are there? This is the first question. The second question is if each school must receive two teachers, what may be the situation here? These are the two questions we need to answer. For the first part, let me consider this to be the first part, and from what onward, it is the second part be there. Okay, from the what if it is the second. So there are eight teachers divided among four schools. So for the first teacher, it is for the first teacher T1, how many possibilities are there? Where he can go? The answer is there are four possibilities. Out of four school, he can go anywhere. How many possibilities are there for the second school? So second teacher, the answer is again four schools are available. For the third, again four schools are available. Fourth teacher, again four schools are available. Fifth teacher, again four schools are available. Okay. For the sixth, again the same. Seventh, again the same. And eighth, again the same. So any teacher can go in any of the four schools. So how many total such permutations, so total such divisions are available? The answer is you need them together. So it is going to be 4 to the power 8. So there are 4 to the power 8 such divisions. Okay, there are 4 to the power 8 such divisions. I hope no issues are there. Every teacher have four possibilities where he can go. Now in the second case, B part, if each school must receive two teachers. So that means to say that out of eight, you need to divide them into group of two, two, and two. There are four such possibilities there. Okay, every school must receive two there. So now because you are going to divide them into equal number of parts, I wish to include one statement from the beginning. I included the case. Okay, I may discuss them later on. Division into groups of equal size. The number of ways in which mn different objects, here mn is going to be how many? It is going to be 4 into 2, that is 8 there. There are 4 groups. Divided into m groups, you have to divide them. Now,
Thank you, sir.
the question here is dividing mn different items into m groups there. Okay, how many groups are there? 4 groups, each containing an object, and the order of the group is not important. The order is not important. It is going to be mn factorial. That means for this particular case, if the order is not important, it is going to be your mn, that is 8 factorial divided by 2 factorial power 4 multiplied by 4 factorial if the order is not important. But if the order is important, because you have to distribute them, teachers, you have to distribute among the schools. So whenever number of ways of m and different items can be divided equally into m groups, and each containing an object and important wording, the order of the group is important. Whenever the order is important, because you are going to distribute the teachers there. There are four schools. If one is two teachers go here, then after other, so you can have the permutation also there. So whenever the order is important, in that case we just multiply by m factorial. In this case, this is the formula we are going to use. Okay, this is the formula we are going to use. So we use this formula whenever the order of the group is important. We use this formula when the order of the group is not important. Any doubt there? I hope no issues are there. So for this particular case, if you see, yes, for this particular case you see, because in this case order is going to be important. You are going to divide the teachers into four groups. It is going to be 8 factorial. Basically, I should use multinomial. So you will learn 8 is divided into 2 parts. 8 is divided into these four parts. It is going to be over 8 factorial divided by your 2 factorial, 2 factorial, 2 factorial, 2 factorial. And I'm writing here order is important. Writing the statement here. Order is important here. Whenever you assign the teachers to for school, order is important here. Okay, so in this case, it is going to be 8 factorial divided by 2 factorial, and whatever you know the answer, it's an easy task for you. I hope up to this point, everything should be understood. We are having four more questions. Let us just try to answer the seventh question there. In the seventh question, the question here is going to be, in how many ways can man divide 7 gifts among 3 children? If eldest is to receive 3 gifts and the other two each, and the others two each. So the question here is, there is an elder who is going to get how many? 3 gifts is there. So certainly out of 7, you need to have 3 there. Then after 2 is. So check. So 7 is going to divide into 3 part. 1 is 3. Then after 2. Then after 2. Is it so? Yes or no? Just have a look at the statement. Just have a look at the statement. Let me just check my solution first. Give me a second, please. There is another, the answer for this question is going to be 7 factorial divided by 3 factorial, 2 factorial, and 2 factorial. There is other way of doing the same question. Out of 7,
4C2.
you just distribute first 3 to the eldest one. Then after the remaining 4, out of the remaining 4, you just distribute
4C2.
2. And then after out of the remaining, you just distribute 2.
4C2.
So when you calculate them, you will get the answer, and I hope you will get the same type of answer. Next question, 8 there. We have seen one example also based on the same question. Consider n digit number. Each digit is made up of these 10 digits 0, 1, 2, 3, 4 up to 9. How many such numbers are there for which no two consecutive digits are equal? For this case, let me just suppose n is going to be 5. So you need to tell me 5 digit number, and any digit can be can have 0, 1, 2, 3, 4, whatever you need. So now the only situation is no two consecutive numbers are there. So how many possibilities are there for the first place? The answer is there are total 10 possibilities, because there is no such no integer yet. You can have 10 possibilities here. For example, just assume that you have fixed 2 there. So if 2 is there, how many digits cannot appear here? The answer is 3 cannot appear here. But yes, there are 9 such possibilities. 9 other digits can be there. See, you cannot have 3 at the second position because 2 is at the first place, but you can have 9 possibilities are there. Okay, just fix any such like the 0 you have. 0 you fixed at the second one. So how many possibilities are there for the next case? Now you check. Other than 0, other than 1, sorry, you can write you can have the next digit other than 1, because 1 is the next consecutive term. So how many such possibilities are there? Out of 10, I cannot have 1 there. Same situation, out of 10 I cannot have one next term, and out of 10 I cannot have one next term. So how many total such possibilities are there? The answer is going to be 10 multiplied by 9 to the power 4 there. Consecutive stands for, if 2 is there, the next consecutive term is going to be 3. 3 should not be there. This is what I have assumed. So what should be the answer for the first case? So the answer for the first case is going to be how much? 10 multiplied by, how I get 4 here? Because total 5 digits I was looking for. So 4 is going to be 5 minus 1. So in the same way, I'm writing the answer here like 10 multiply 9 power n minus 1, because total n digits are there. Now let us talk about the B part. What is the situation if 0 appears as a digit a total of I times? Out of the n time, just suppose for example n equals to 5 there, I assume that r equals to 3 times 0 appears. So 1, 2, 3, 4, 5 places are there, and 0 is appearing 3 at 3 places. I do not know at what places 0 is appearing. So how many places are there at which 0 may appear? The answer is going to be, out of 5, choose 3 positions. So let us choose 3 positions. 0, 0, 0. These are the 3 positions we have. These are the 3 positions you have. So now I fixed 3 positions where I can have 0. Now, the situation here is, out of 5, you have 3 places at which 0 is there. So, if you have to take only 0, 1, 2, 3, 4 up to 9, 0 already we have taken into account. There are 3 places where you can have 0. So, how many digits are possible at the left out positions? Only 9. Any route? Only 9 is possible here. Why? We cannot have 0. 0 already fixed. So that means to say that it is going to be 5c3 and 9 power 5 minus 3 there. In a similar way, Number of digits are going to be out of n places, total I times 0 appeared, and the remaining you have non-zero number. So it is going to be 9 to the power n minus I there. This is how you can find the answer. This is the B part. I hope no issues are there. So the answer should be understood by now. Next, we have an expansion like the 3x square plus y power 4. I think we have discussed expansion in the previous class also. So let me just leave it for the moment. Let me just try to understand this 10th question, A part. Okay, let me try this A
Yes.
part. I did the B part maybe in the last class also. A part is
Yes.
certainly easy there. So you need to recall the binomial theorem. Binomial theorem stands for summation. Your k goes 0 to n. N is 4 here. Okay. Then after it is going to be nck. N is 4. K is going to be 0 to 4. Your first term, whatever the first term you have, 3x square. You can choose this to be k or n minus k depending upon you. I'm choosing it like n minus k here. And the second term is going to be y power k. If you wish to take another notation from k goes 0 to 4, it is nck there. N has the value 4, I already told you. You can assume 3x square power k and y power n minus k, whatever suits you, you can use them. Both are going to give you the same answer. Okay. For that, you need some notations also. You need some values like 4c0 is equals to 4c4. It has the value 1. 4c1 is equal to 4c3 is equal to 4, and 4c2 is going to have the value 6 there. These are the NCR type of numbers. You already know them. Now let us try to find the answer for the A part. Now for the A part, if you do the expansion, maybe I'm using this first part, then put k equals 0 there. If you put k equals to 0, it is 4c0, 3x square power 4 minus 0, and y power 0. This is the first term. I used k equal to 0. If you use k equals to 1, it is 4c1, 3x square power 3, y power 1. You can just substitute k equals 1 here, n equals 4. So n minus k is 3, y power 1. Then after 4c2, 3x square power 4 minus 2, and y power 2 there. For the next case, it is 4c3, 3x square power 1, y power 3 there. And for the last case, it is 4c4, 3x square power 0, y power how much? 4 there. Anything power 0 is 1 there. So this term is 1, this term is 1. And rest of the terms, we already have the values for them. 4c0 is 1. Always remember, whenever a b whole power n is there, it is the same thing like a power n, b power n. So for the first case, it is 3 power 4, x square power 4. Y power 0 is 1, so I'm not writing there. 4c1 is 4. Then how to deal with this 3x square? It is going to be 3 power 3 and x square power 3 with y having power 1. 4c2, I have the value 6, 4c2. Then after expand this term, it is going to be multiplied by 3 square, x square whole square, y square. What is the next term? Similarly, 4c3 has the value 4 there. It is multiplied by 3, then after x square, then after y cube. And 4c4 is 1. 3x square power 0. Anything power raised to the power 0 is going to be 1 for you. Y power 4. Now simplify them. 3 power 4 is 81. X square power 4. Always remember a power m whole power n is going to be a power mn. So x power 2 whole power 4 is going to be how much? X power 8 there. Okay. Now 3 power 3 is going to be 27. 27 into 4 is going to be how much? I think 108. You just check that calculation. I may be wrong here. How to simplify x square power 3? It is going to be x power 6 there using a power mn formula, y as it is. 3 square 9 into 6 is going to be 54. X power 4 y square. Then after 4 3s are 12. X square y cube. And the last term is going to be y power 4 there. So this is how you can expand them. Okay, this is how you can expand them. I hope no issues are there. Similarly, if you wish to do the next part, B part, you have to find out x1 plus x2 plus x3 power 3. Yes, you can have 2y in place of x2, 3z in place of x3. Okay, so how can we expand them? We need to find out all the solutions for the equation x1, x2, x3 equal to 3. How many solutions are there? There can be solution 0, 0, 3. There can be solution 0, 3, 0. There can be solution 3, 0, 0. This is one such partition. I'm just trying to have the partition. Then another partition you can have like 1, 2, 0, 0, 1, 2, okay, 2, 1, 0. Then after over 2, 0, 1, there will be 6 such possibilities there, 1, 0, 2 there, and 0, 2, 1. Have we taken all the possibilities? I hope yes. These are the 6 such possibilities there. There were 3 possibilities. And in the end, you will be having 1, 1, 1. This is one such possibility. So in total, I will be having, I think, 3 plus 6 plus 1. How many terms are there? 10 terms will be there. Okay. I think I discussed on the same with you. If I need to find the total terms, the answer is going to be n plus r minus 1, r minus 1. Okay. So what is the n there? N is 3 basically. 3 plus 3 minus 1 and divide by how much there? It is going to be 3 minus 1, that is 2. So I hope it is going to be 5c2. I hope you remember we have discussed this similar type of question, that is the number of non-negative solutions. Non-negative solution of the equation x1 plus x2 plus x up to, I should use dot 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 up to xr equal to n. And 5c2 is going to be 5 into 4 divided by 2 factorial. The answer is 10 there. And we are getting the same number of solutions here. Now, corresponding to each partition, you will have a term. For example, if you consider this to be first, so what is the term corresponding to this? It is going to be 3, 0, 0, 0, x1 power 0, first term, x2 power 0, and x3 power, how much? You should have here 3, x3 power 3. You can place x2, you can replace x2 by 2y, x3 by 3z, and x1 by x. You will get the answer. You need to replace x1 by x, x2 by simply 2y, x3 by 3z, and you need to just calculate them, nothing else. Corresponding to the second term, second partition, you will have a term 3, 0, 3, 0, having exponent x1 power 0, x2 power 3, x3 power 0 there. If you look for the third term, you will have the next term like 3, 3, 0, 0, x1 power 3, x2 power 0, x3 power 0. And for the answer, you need to replace x1, x2, x3 by these three. I already told you. Next, for these, let me consider this to be the fourth partition. Corresponding to the fourth partition, you will have the multinomial 3, 1, 2, 0, x1 power 1, x2 power 2, and x3 power 0 there. Agree? Corresponding to the fifth one, and so on, this will be the last one. You will write all the 10 terms if I ask you about the expansion there. Multinomial 0, 1, 2. So 0 is there, it is x1 exponent, 1 is there, it is x2 exponent, 1, and 2 is there, it is x3 exponent, and up to so on. So you will have 10 total terms, 10 terms in all. Okay, you're going to have 10 terms in all. Is there any doubt? I
No,
hope
sir.
no
Thank you.
issues are there. And this A part and B part we have already discussed. Now, this is the last question we are going to discuss now. And after this, practice sessions and almost everything is completed. If there is any doubt, maybe in the beginning part, you just let me know. I'll create a video for the same and I'll send you. How many subset of size 4 of the set 1 to 20? You need to take 4 at a time. Out of these, contains at least one of them. At least one of them. So whenever you have to take always at least one of them, so there may be a situation that out of these 5, you choose one, and then after remaining out of 15, because there are 20 in total. So out of 5 you choose one, and the remaining 15 you choose 3 there. Total 4 is required. There may be a possibility that out of 5 you choose 2 there, because at least one is there, and the remaining 15 you have from 6 to 20, you can choose 3. There may be another possibility that out of 5 I choose 3, they will satisfy the condition at least one of the 1, 2, 3, 4, 5 is chosen. The remaining out of the remaining, oh sorry, it should be 2 there basically. Out of the remaining 15, let me just choose how much? 1 there, because in total I need the size to be 4. So 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4. In the end, out of 5, let me choose 4. 4 from 1 to 4, 5. And out of 15, let me choose 0. If you calculate them, it will give you number of ways of selecting 4, okay, with the condition that at least one of the element is from 1 to 3, 4, 5. I hope no issues are there. So with this, we have completed the first task. I'll send you the notes and I'll update this.